Hi all, and welcome to the last lesson that we have of our unit on rational numbers and data, so chapters 3 and 4. As you've seen by now, you are going to have a test next week, so start scheduling those Zoom meetings and start getting on Google Classroom and checking for any missing homework. I'll be available for help whenever you need. Just be sure to reach out and let me know. So our last lesson is going to be about scatterplots and how we use them to interpret data. And your homework's going to be from 4.7. So get yourself ready for notes and we're going to get started. Now, a big thing, we've got some pictures of scatterplots here that talk about the correlation that you can possibly see with data. So we can see things that are positively correlated, which means that the arrow or the data kind of goes in an upward direction. No correlation, which means that it's all just kind of random looking, and then negative correlation. But what do all these words mean? So the correlation right here is the relationship, notice the root similar, between two variables in a data set. So positive correlation just means that when one variable increases, the other one increases, which is what we see here. If we're going higher numbers this way, we're also seeing higher numbers this way. So one example of positive correlation would be a child's age and their height. Children get taller as they grow older. Another example would be the distance traveled and the time that you've spent traveling. The longer you spend traveling, the more distance you have covered. Now, we also might have something like no correlation, which is what we see here, meaning that they don't have a relationship. So if you see something like this, it's possible to have no correlation, which means that the variables are not in any way related. So if we're talking about something like no correlation, we might say a child's age and the age of their parents when they chose to have a child. Those aren't related. If you have a kid at 30 versus having a kid at 25 versus having a kid at 50, the child's age is not affected by your age. Now, we also might have a negative correlation. And what that means is that one variable increases, the other variable decreases. So for example, distance driven and the amount of gas in the car's tank. If I drive for 30 miles, I will have less fuel, but I've covered more distance. And that's where we see where one is increasing, the other one is decreasing. We also might say low or high correlation. If they have high correlation, positive or negative, it means that they are closely grouped. They follow a pattern very closely, versus low correlation, which is where they have a relationship, but they're very loosely grouped. Now, with number 1, it asks, for the data sets below, determine if they have positive, negative, or no correlation. So number 1, a population of a state and the number of senators it has in Congress. Now, this has no correlation. If you remember your history lessons, all states, no matter the population, have 2. So all states have 2 senators. And it doesn't matter if it's California, which has millions of people living in, or if it's something like Rhode Island, very, very small state, with a much smaller population. All of them have 2. Now, number 2, the population of states have the number of representatives it has in Congress. Now, this, you maybe remember, is positively correlated. Senators always stays the same. Representatives increases as you have more people in your state. Number 3, population of a state and the number of senators per person. So now you'll notice that this is very similar to number 1, but slightly different. This is a negative correlation. And what that means is you still only have 2 senators for every state, but when you divide them by a number of people, if you divide them by a larger number, the bigger the number in the denominator of a division problem, the smaller it gets, right? So if we increase what we divide by, that means that we decrease the answer. So this one is, if this is increasing, then the answer is decreasing, meaning it has a negative correlation. Now that we've introduced our vocabulary, let us actually make a scatter plot. So here we have a data set about longevity, which is the lifespan of an animal. It's measured in years. It's already labeled to us. We have average and we have maximum. And they've already done this for us. They put average on the x-axis here, right down here, which means that this is our x-coordinate, and then maximum, which is our y-coordinate. So this first point that I'm going to graph is 1247. So that means that on our x-axis, we're going to go to 12, which would be approximately here. And then we will go up to 47, which would be right here. And the place where those intersect is our first data point. Next, we've got 25 and 50, which will be right here. If you want to pause the video now and fill it in on your own, or fast forward ahead to see it completed, you can. I will finish drawing in all of our coordinates. We have 15, 40, 8 and 20, 70, 35 and 70, 40 and 77, 41 and 61, and 2054. So there's our scatter plots. If you're asked to create a scatter plot, this would be the result. We can also use our scatter plot to draw what we call a line of best fit. And we use that just like we would use a line graph from our earlier lessons to estimate. So our line of best fit is the line that best approximates the correlation. So if we scroll back up to the top or we turn our page back over, these right here are our lines of best fit. They approximate our data, just like that. And since they're approximation, everyone's are going to look slightly different, but we're going to try sketching it in. I'm going to sketch mine in right there. Of course, everyone's going to look different, but what you want to make sure that you're doing is that you have some points above the line, some points below the line, and that it's looking like it's following the trajectory pretty closely. Now, once you've drawn in your line to the best of your ability, you're going to use it just like we did for the line graph in our last lesson. This one is asking, what is the average lifespan for an animal 30? What would we predict the maximum is? So if here's 30, we go right to here. And on our lines, on my line, it looks like it's 60. Again, that's going to be my estimation. I'm going to say, well, the maximum is going to be 60 years. Now, of course, not everyone's line is going to be exactly the same. So if you're anywhere in between, I think 55 and 65, that would be a reasonable approximation of the maximum longevity. Please let me know if you have any questions about this lesson or anything in this unit, and I look forward to talking to you all during our Zoom meetings.